All right, welcome back. This is going to be a pre-calculus problem. We are going to be graphing the polar coordinate r equals 1 plus 4 sine theta. All right, hold on for just a second. I'm going to stop you for a moment, pause you. All right, I needed to get a calculator just in case we're going to do something a little bit later. So usually when I ask these problems, there's a step one where it says graph the problem in Cartesian coordinates and then graph the problem in polar coordinates. So going through and graph the problem in Cartesian coordinates, we're going to say 1 plus 4 sine theta. So we're going to go ahead and do this. Let's see, here's my y equals 0. Okay, so here is 1. Okay, and then we have to go ahead and graph sine. So we're going to go from 0 to 2 pi. Halfway between there is pi. Halfway between there is pi over 2. And halfway between pi and 2 pi is going to be 3 pi over 2. Okay, so 1 plus 4 would be 5. So 1, 2, 3, 4, 5. We're going to be all the way up here. I'm going to go ahead and draw a little dotted line here. So that's like my y is equal to 1 axis here. And we can go ahead and start dotting in our sine function here. So we're going to say, okay, we have 1 at pi over 2. Sine of pi over 2 is 1. So we have 1 plus 4 is 5. Back down to pi, we're going to be 1 plus sine of pi is 0. So back down to 1 here. When we get to 3 pi over 2, we have 1 plus 4 times sine of 3 pi over 2. That's going to be 1 plus 4 times negative 1, or 1 minus 4, which is going to be negative 3. So when I'm looking at my graph over here, we have 1, 2, 3, and we'll figure out we're going to be down here somewhere. Okay? And then, of course, we get back to 2 pi. Sine of 2 pi goes back to being 0, and we come back up to here for it. So let's just sketch this thing in. So we are going to be able to do something like this. And we have a graph going on over here, and we have a graph up here. Let's just pretend that hit all the dots. Okay, so a couple of things that we have to deal with is that we realize that the function crosses the 0 at 2 places. Okay, one of the questions I'm going to have for you on this problem, it may not be listed, but it will be on your exam, that what angle did it cross at? What was theta when it crossed that? And I usually let you guys go ahead and answer that in degrees. That way you can get a good idea of what's going on. Okay, so once we have I'm going to go ahead and say that's theta, and this is r. So we label our axes a little bit to kind of say like it's Cartesian, but we still have an r theta kind of an axis thing. Now we're going to go to our polar graph. Okay. And polar graph, instead of doing this as x and y, what the angle is going to be our theta. So we say that's 0 to 0 radians. Here is pi over 2 radians. Here's pi radians. And of course, we have pi over 2 radians, 3 pi over 2 radians down here. Okay. So as I'm looking at my little graph up here, we're going to say, okay, when we have when we are at a theta, an angle of 0, right? Theta is equal to 0. R is 1 unit out. So I'm going to come out here and try my best to estimate we have 1 unit out. Now, as theta increases between 0 and pi over 2, what happens to my graph? What happens to the graph? It raises from 1 all the way up to r is equal to 5 up here. So we're going to say, okay, let's go with 1, 2, 3, 4, 5. So I started here, but by the time the angle comes up here at pi over 2, we've got to come all the way up here for pi over 2. Okay? Now, once we go from pi over 2 back down to pi, right? So I'm looking at stuff in the second quadrant here. I can go ahead and say it's going to be over here someplace, right? Quadrant number 2. We could say, okay, we're going to come back over here. It's going to be 1. Okay, and as we fall from pi over 2 down to pi, which is this angle over here, okay, it's pi, we're going to have our angle is going to fall and it's going to come in like that. Okay, now it gets to be a little bit tricky because we are at pi, somewhere between pi and 3 pi over 2. So if I look at that and I say, okay, it's down here somewhere. Okay, it's down here somewhere. Somewhere in this angle, the function comes in and actually crosses the origin and crosses the 0 point. Okay, so what's going to happen is that we're going to keep going around. When we get to 3 pi over 2, right, we get down here, all right, we get down to 3 pi over 2. we have to walk backwards, and we're going to walk backwards 1, 2, 3 steps. So we're going to walk up here backwards 1, 2, 3. So we're actually going to come up here somewhere. So our graph is going to kind of cut into the origin. It's going to come around like this piece right here. It's going to come around like that piece down there. And when it finally exit my curve, right, we're back in the positive realm here. So Y's are all positive, or R's are all positive again, and it's going to do something like this. Okay, so that's what this thing should kind of look like as we go through to graph this piece. Okay, one of the things I'm going to ask is what angle did the graph cross its origin, or what angle did the graph cross into, like kind of going to the upside down world here. So the way we're going to do that is we're going to say, okay, 1 plus 4 sine theta equals 0. We have to solve this. So we can go ahead and say, okay, subtract 1 from both sides. We have 4 sine theta equals -1. Sine theta is equal to -1/4. So theta is going to be the inverse sine of -1/4. Now, you'll forgive me for a moment because I know that inverse sine is going to give me an angle in the fourth quadrant, and it's going to give me a negative angle. I'm not usually going to want a negative angle. I'm usually going to say something like 0 theta to 360. We'll go ahead and make that degrees because it'll be easier. Okay, so I'm going to say my theta ref is my reference angle is equal to my sine inverse of just 1/4. It's like, why would you do that? Because I want to know what it's going to be like in the first quadrant so I could translate it to the third and fourth quadrant as a positive angle. So we can go ahead, let's check our modes here. So we are in degrees. Okay, and we're going to say the inverse sine of 1/4. Okay, let's say ta-da, we have 14, we'll say 0.48 degrees. Okay, so we have 14.48 degrees here. Okay, just double checking that one. Yep, 14.48 degrees. Now, where the heck is this? So we know that it's going to be beyond pi. We can go back up and look at our graph way up here. It's after pi, so it's going to be in the third quadrant and the fourth quadrant for where it kicks over. Okay, so we need this in the third and fourth quadrant. So I need an angle down here, right? And this angle, and an angle in the fourth quadrant, an angle down here. So we can just say all the way over there like that. Okay. So in order to get this first angle, it's going to be 180 plus 14.48 degrees here. Okay. So we end up with 194.48 degrees. So that's my first angle where this thing crosses. The second angle, we can say, okay, it's going to be 360 minus 14.48 degrees. That's going to give me this thing up here. I'm going to be exceptionally lazy about this and say, okay, we have 360 minus 14.48 degrees, and we end up with 345 degrees. My theta 2 is going to be whatever the heck this was. It was 345.52 degrees. 345.52 degrees. Okay, so that would be all of the things I could possibly ask on this question. Right, that's how you graph a polar coordinate. That's good. And that also tells me at what angle that this thing comes in and goes out on the other place. When you take your calculus classes, you're going to have to leave these in radians, right? And we could figure that out as well. We could either do the whole thing in radians and do it that way, or we could translate these angles from degrees into radians to make sure that we have this done right. But this is the first time you're doing it. This is the first class you're doing this in. I think degrees is sufficient for like showing you how to do it, and it doesn't rob you of like the familiarity you have with degrees when you're trying to figure out like where the heck is this stuff supposed to be. Okay, so that's how you go through and do that problem. I'm going to say thank you very much for watching the video. Good luck studying, and I'll see you in the next video.